Welcome back to our live sessions. We are in week 18. I know it's been a while since we have had a live session because of 11th grade testing, but I'm grateful for those of you that are here in person with me today. We are going to cover the end of Unit 5, which includes frequency distributions, normal distribution, correlation, and lines of best fit. Hey, McKenna, you can grab the notes right there. As we work through today's lesson, your essential question is going to be given somewhere during the session, so I just want to make sure you're paying attention. I'm not trying to trick you. It will be very obvious pre-printed on the screen for you. Through K-mail, I sent you 2 different versions of the notes today. One version I sent you of the notes has one slide per page, so it would be about 12 copies to print out. The other version is 3 slides per page. The 3 slides per page, some of the numbers get kind of small and it's hard to see. So if you're in person, I actually give you a 12-page copy. That way they're nice and big for you today. So again, week 18, just keep a lookout for the secret phrase that will be given sometime during the session. Before we jump in, I do have to say this is one of my least favorite sections. It's just kind of boring and dry, but we will get through it the best that we can. It's kind of the end of wrapping up of our year. After our conic section, we're back to some probability and statistics. Maybe this is right up your alley. I know in college, sometimes you have the option to go the statistics route or more of the algebra route, so you can kind of get a feel for which one you might like a little bit better. So let's take a peek at my first example, and of course I'm showing you my answer. Darn. Okay, here we go. A random sample was taken from town accident reports last month. 20 of the 30 accidents that occurred last week involved red cars. In the past week, 350 accidents were reported in the state. Based on this sample, predict how many of the 350 accidents involved red cars. I think when you guys watch the news and you hear about all of these statistics and there's this many murders worldwide, or there's this many things happening in the state of California, it's a prediction. So it's not like they're going to go out and they're going to tally every single one and add them all together for the whole nation. They're doing a prediction based on a small sample size. So that's kind of what's happening here. So let's highlight a couple things in our notes. So let's reread that second sentence and underline any keywords. It says 20 of the 30 accidents. Well, I bet those are going to be important. So 20 of the 30 accidents that occurred last week involved red cars. How can we represent that as a proportion? 20 of the 30. What would that look like as a proportion? Anybody know? 20 over 30. Good job. So 20 of the 30, that's just a proportion. In the past week, 350 accidents were reported in the whole state. So based on this sample, we're probably going to use 350. Predict how many of the 350 accidents involved red cars. I kind of highlighted the words of the because in math that means something specific. How many of the? What does the word of mean in math? When you hear the word of. Not divide, close though. Multiply. Of means multiply. So I'm going to take my proportion and I'm going to multiply by 350. So if on our small sample size, 20 of the 30 are red cars, and in total, my big sample, I have 350 cars, when I multiply them together, that's going to give me how many red cars there would be for the whole state. So let's work that out. Has anyone ever, let's try that again. Has anyone ever taught you the rule about dividing with zeros at the end? How to simplify that? Yeah, you just cross them off, right? Because that's the same as dividing by 10. They can just go away. So now across the top, I'd have 2 times 350, which would be not 800. I did that wrong. 700. And on the bottom, we would have 3. So if I divide 700 divided by 3, I get about 233.3. Can you have 0.3 of a car if we're talking cars? No, so we're going to round, right? That's what they do in real life too. They're just going to round. So we would have about 233 red cars out of the 350 accidents. So take a quick second to write that sentence at the bottom that sort of describes what's happening. So 233 red cars out of the 350 accidents. So I'm going to have you try an example that looks a lot like this, but you're going to work through it on your own and we'll see how we do. Are there any questions how we set this one up? We took our first two numbers and made a proportion. Then we learned that the words of the means multiply, so we're multiplying it by the total to find our small amount of our sample size. Okay, so here's your example. It says, a random sample was taken of favorite food types. 15 out of 100 people chose Italian food. Approximately 500 students attend SCOA. Predict how many of them like Italian food. So let me give you a moment to try and figure that out. You will have quiz questions that are just like this one, just with different numbers. So if I have 15 out of 100, Alex, how do I write that as a proportion? 15 over 100, good job. And Kayla, what am I going to do with this 500? What do I do with my 15 over 100 and the 500? Good job, I'm going to multiply. So I'm taking my small sample size, here's my small sample size, multiplying it by my large total to get my new approximate, right? It's my prediction. Is it going to be perfect? No, it's just a prediction. So I'm going to do some cross-canceling to reduce. So 100 goes into 100 once, goes into 500 5 times, and 15 times 5 would be 75. So if 15 out of every 100 people like Italian food, that means 75 out of the 500 would like Italian food on a bigger scale. Any questions how we set that up? Okay, perfect. So next we're going to move into frequency distribution. I'm asking you a couple different things here. I want us to make a frequency table, and we're going to use the table to draw a histogram for the data set. So we're going to make a table first, then we're going to draw a histogram second. Can you underline those two things? That way you have some vocabulary down for when we actually do these problems. So here are some questions we need to ask ourselves. When I'm making a table, how many groups should I use? And how do we decide how many groups to use? So think about what a frequency table is. A frequency table is where we're going to list the numbers and how many times we see those numbers. So I don't just want to say 24, 25, 26. Oh, I have a 24. I don't have any 25s. I don't have any 26s. We don't want to do it by ones is what I'm saying, because we're going to get such a small grouping if we do it by ones. So what could be something else we might want to try? Anybody have an idea? And what if I told you there's more than one right answer? There's not just one right answer. So here's one way that you could sort of help yourself decide. We're going to pick out our lowest number, and then we're going to pick out our highest number. So can you guys take a second and find those two? Okay, what's the lowest number up there? 20. What's the highest number up there? 68. 68. Good job. So if I'm rounding, because remember when we do our tables, we're not going to go by ones. We're not going to say 20, 21, 22, 68. So if I'm rounding, 20 is already rounded, but we can think of 68 as rounding to 70. That way we're talking whole numbers now. So what kind of a span of numbers am I talking about? I'm talking about 70 minus 20. We're talking about a span of 50 values. You guys okay with how I came up with that? This is not the answer to any part of our problem. It's just helping us determine how many groups I want to do. So we're going to take our highest minus our lowest, and that gives us our range of numbers. So we're talking about numbers within a 50 different number span. From here, we get to pick how many groups we want to make, kind of like I was talking to you guys at the beginning about that. Let's try 10 groups this time. So I'm going to put over here in the corner, we're going to make 10 groups. If you said, I want to make 8 groups, fine, that'd be fine. There's no wrong answer. On a test or a quiz, you don't get a pick, right? You're just going to look at their frequency table and see which one they picked. We're just practicing from scratch, even though you don't have to do that on a quiz. We're going to take our total span, which is 50, and divide by how many groups we're going to do. 50 divided by 10 means I'm going to put mine into groups of 5. And when I say 5, here's what I mean. We're going to put 20, 21, 22, 23, 24 together. The first 5 numbers are going to go together. Then we're going to put 25, 26, 27, 28, 29 together. We're going to put them in groups of 5 together. Here's what our chart's going to look like. So on your next page, I gave this to you already. If you flip your notes, we put them in groups of 5. So from 20 to 24 is actually 5 different sets of numbers. Think about it. Let's count it out again. 20, 21, 22, 23, 24. That's 5 numbers. When you subtract these two, you're finding the difference between the two, which would be 4. But how many total numbers are we talking about? You have to include the beginning and the ending number. So you can't think of subtraction when you're putting them in classes or into groups. It kind of throws us for a loop because we forget to count the beginning and the ending number. So we want groups of 5. So 25 to 29, let's just count on our fingers one more time. 25, 26, 27, 28, 29, that's a group of 5. See how it can kind of be a little bit misleading when you're putting them into groups. I just want to make sure you understood how they did their groups of 5. What does frequency mean? How many times the number happens or occurs or shows up? So if I went back to my chart, I could have you count how many times you saw each of your groups occurring, but I did it for you in this case. So this section, there were 4. This section, there were 3. This is called the table. So next to this one, can you guys write the word table? So if a quiz or test asks you to make a table, that's literally what you're doing. You're making a table with rows and columns where you have your data. Any questions about this one? They call it a class. You could call it a group. You could call it a set. You could call it whatever you wanted to call it. That wording is not official wording. It's just what they chose to call it. The bottom is actually called the histogram. So let's go ahead and write that word on it, histogram. A histogram is more of a bar graph. That's really what we used to call it, back in 6th grade, because you probably thought, oh, a histogram, that's a scary word. It's just a bar graph, which we've been doing forever. So notice across the bottom, they have their same groups of classes, just like we have up here in my table. We're just representing the information in a different way. This time we're doing it in a histogram format, which is a bar graph. So my group from 20 to 24 had a frequency of 4, 25 to 29, occurrence of 3 times. Once you have your table, is it pretty easy to make your histogram? Yes, as long as you recognize it's just a bar graph that we've been doing before. Questions? So on a quiz, they might ask you, which one is a good histogram? So notice what makes this a good histogram is that my y-axis goes by 1. It's consistent, right? My numbers are consistent. And my x-axis is also consistent because these are in groups of how many? 5. What would not be a good frequency table is if this was a group from 20 to 21, then this one was like 21 to 30, then this one was like 40 to 90. It wasn't consistent. So what makes something a good frequency table is consistency. Consistency on the y-axis, consistency on the x-axis. Does that make sense? Because I know they're going to ask you that, for sure. Now we get into the not so fun part, but I will make it as painless as possible. This is called a normal distribution. Have you guys ever seen this shape of a graph before? A couple times? Do you know the generic name for this? Starts with a B. Let's add it on here. It's called a bell curve. Back in the day, teachers used to grade on a bell curve. And what that would mean is, if here was your whole class, right, here's your whole class, a few people are going to get F's, a few people are going to get A's. Where are most of the class going to be at? A C. So at some colleges that were really, really strict, they would only let a certain percentage of their students have the A, certain percentage were going to have the S, most of the students were going to end up with the C in the middle. So you can miss one question on a test, but because 3 people got 100, they got an A and you got a C. So some teachers actually grade on a bell curve at some colleges. I chose not to go to one of those because it freaked me out. But here's what a normal distribution is. What this means is that the majority of the class or the majority of the data are going to fall within the middle values. So I know we're going to get into all these terms in a minute, but let's just understand the general first. So again, a bell curve is where the majority of your numbers, the majority of your groups, the majority of whatever we're talking about occurs in the middle section. We've heard of percentiles before when you guys used to take tests when you were little and they would say, you are in the 98th percentile. Did you ever take tests like that? What a percentile means is if you got in the 98th percentile, you are way above on the bell curve. You're like way over here. 98% of people scored less than you did. So whenever we're talking percentiles, that's how high you are, saying you are above that many other people. So that's what a percentile means. They're talking about this crazy bell curve, actually. A couple quick new symbols for us. This is called mu, M-U, mu, which is kind of strange. It means the mean. So let's circle this and underline the word mean. It's almost like I don't know. It's like a U, but like with the extra line on it. Like it's just kind of funky looking. That's kind of like an upside down H, but with this extra little line on it. It's just bizarre. What does mean mean? What's the mean? The average. Yeah, let's write that. The average. So that crazy little Greek symbol means the average of a set of numbers. An S means standard deviation. So the S is going to be the standard deviation of the whole sample. And then this symbol means the standard deviation away from the middle. We'll talk about those two in just a minute. So let's say the majority of our class, putting this in simple terms, let's say the majority of our class got a B on the last test, okay? Everybody with me? The majority of our class got a B. Students who are one standard deviation away from the middle maybe got the next grade level up. Maybe they got the A, and then there were very few A pluses. So a standard deviation is telling you how far away you are from the middle, from the average. And we're going to practice how we find that number today. So if the average of the class was a 45%, you would hope to be really far away from that average, right? If you did a good job. You want to be really, really far away if the rest of the class doesn't do a very good job. So we're going to practice finding these new ideas today. So using the normal distribution curve, and I made it really big for you here, these numbers are not made up, by the way. These have been researched and tried and true method of when we're talking about a normal bell curve, what percentage falls within each range. This is just the normal chart that's used everywhere internationally. So if I'm using this normal distribution curve, what percent of the data are within 2 standard deviations of the mean? So let's find the mean. The mean is where again? In the middle. Okay, so let's all sort of highlight that or make that bolder with our pencil. And it wants within 2 standard deviations of the mean. So that means I'm going to go 2 sections to the left. We're okay with that for 2 standard deviations. And I'm going to go 2 standard deviations to the right. So it's asking what percent of the data are within 2 standard deviations of the mean. So they want to know how many people are going to fall in this section. How am I going to find that number? What do you think I need to do? If this section right here is 34% of the population, this is 13.5, this is 34, this is 13.5, how am I going to find my total that falls in my shaded section? What will I do? add it together. Exactly. So let's do that. Does this what? Yes, but I want you to know how they got the bottom. Okay, so I got 95%. Is that what you guys got? And yes, Anna was correct. I was going to point that out in a minute. I just wanted to make sure you knew how they got those numbers. Because sometimes we look at a chart and we're like, oh, they put a number there. But we're like, where'd the number come from? Right? So they don't have to give us those numbers for us to be able to answer the question. And on a quiz, they wouldn't put those numbers at the bottom. You know what I mean? They don't do that for you. So what is that really saying? That means if we take a test and the majority of you got a 60% on it, let's just say my middle of the road students got a 60% on it. That means 95% of the students would only be within 2 standard deviations either way, so plus or minus of that D grade. So like D to a C to a B, D to an F, or like a 0. So that's what standard deviations mean. It's telling you this percent of the population probably only fell within that range. Is this perfect? No. Again, it's a prediction. This unit's all about statistics, predictions, those kinds of things. All right. So let's talk about Albert Einstein for a minute because he is a genius. He is a total genius. Here's an IQ chart. Here's a set of 2,000 IQ scores. Has anybody, I'm not going to ask you your score, but has anyone in here ever taken an IQ test? They have them online for free, if you're interested. Yeah, just to try it out and see where you land. So here's a set of 2,000 people who took an IQ test and they graphed it. What kind of shape is it? It's a bell. It's a normal distribution. So when we tested 2,000 people and their IQ scores, their graph is like a perfect bell, which is what real life is telling us is going to happen to the majority of things. When you guys take tests, if I graph yours would look like a bell curve too, more than likely. So check out where Albert Einstein's score was. He got a 160 plus. Here's all the scores. Here's where he is. He is way above the mean. You guys see that? He's on like the littlest part of the graph right there. That's crazy. So he is at least, if here are my standard deviations, 1, 2, 3. He's like 4 standard deviations away from the mean, which is really rare. That's why the part of the graph is super duper skinny. That almost never happens. The average person is going to be around 100 IQ score. So let's answer these 2 questions. It says about what percent of the IQ scores are below 85? Let's mark up our graph. So here's 85. They want to know what percent is below 85. So take a quick minute, see if you can answer that question. So what did we do? We're just going to add 13.6 and 2.3. So 15.9?
Yeah.
Well, it's, you know, and the question is, can you just round up? It depends on the quiz, to be honest, and what the answers are. But if they give it to you in this format, I would bet that 15.9 would be an answer on the quiz. That's my guess. Yeah, I think it says, doesn't it say mentally? I know it got kind of blurry when I copied it over. So inadequate, low intelligence, average, above, high, superior, exceptionally gifted. So he's way above exceptionally gifted. Well, good for you. But people like that, they're not really, they can't really function in real life. You know what I mean? They're so smart that we'll leave it at that. Yeah, the social aspect just is kind of not all there. Let's try our second question. It says Chen's IQ score was 130. what is his percentile score? So remember how percentiles work again? So if you are in the 80, or let's say 98th percentile, that means 98% of people are below you. So that's how we describe percentiles. So if Chen's at 130, let me mark 130. Here's Chen. Take a second and figure out his percentile. So again, percentile is all about what percent of the population is below you. So that would just mean we would need to add up all the percents that are below Mr. Chen. So Mr. Chen would be what? 97.7 percentile. So even though this curve looks kind of scary, is it pretty easy to use once you get used to it? Yes, I hope is the answer. What's the very middle of the curve called again? The mean. The average is right smack in the middle. And then from there, all of these are segmented by standard deviation. So if here's your first section, this would be 1 standard deviation away, 2 standard deviations away. And again, it's just grouping you into a group of saying, more than likely you are this close to the mean. You're this close to the average. The further you get away from the average, the more likely you are extremely gifted, or the opposite end. And we'll leave it at that. Any questions about this one before we move on? So bell curve is a name for it, normal distribution. What were our other vocabulary words? Bell curve, normal, okay, all those things. So take a quick second. Here is your week 18 essential question response, which is just a quick phrase. It says frequency distributions like being normal. It's like a play on words of reminding you that frequency distributions have a normal distribution, which is our bell curve. Thanks, Nicole. Glad you could jump in. So before I do a little bit more vocabulary, let's talk one more thing about our bottom bell curve down here. So we just talked a minute ago how our mean's in the middle, and this bell curve just did a +1 and a -1, a +2, a -2. What do you think those 1s and 2s represent? The what? The mean is your mu. I know that's like that weird word. So the mean is your mu right here in the middle. Mu. How about these 1s and 2s though? What would these mean? Yes. So these would be your standard deviation. How far away from the middle it is. Remember, 1 standard deviation away is about 34% of the population. That's the only one that I recognize that I have memorized, because in this one little section, you're talking 68% of your students are going to fall in there, or 68% of your data is going to fall in there. So that's what that means, the 1s and -1s across the bottom. Those are your standard deviations away from the middle. So now we're going to learn one last new thing and put it into practice with some numbers, and this is Z-score. Can you circle Z-score? And let us highlight our formula right here in the middle of the page. There's a lot of weird letters going on there. So we're going to put this formula into words. So let's draw an arrow, and let's all put this formula into words. Ready? So your Z equals, X is just whatever value we're talking about. So for now I'm going to say the word score. So your score minus, what does that mu symbol mean again? Mu is the average or the mean. Minus the mean. Divided by, what's that weird sort of like a circle with a flame. Reminds me of like a wheel. Standard deviation. So what a Z-score is going to let us do, it's going to let us compare data that's not exactly alike. Meaning, here's an example for you. Let me cover up all of my work. So Leela's science and government test scores are from different sets of normally distributed test scores. Which score is better relative to the other scores in the class? So think about this. You're in two classes. You're in Mr. Hayden's life science class. You're in Mr. Bremer's government class. In one class, you get a, I'll just show you real fast. Whoa, let's stop there. So in science, you score a 90, but in your government, you score a 92. Which one's really the better score compared to your classmates? That's kind of the question here. Which score is better compared to your classmates? Well, number one, you can't compare it unless you know your classmates' scores, right? Which you don't usually know. But also, each teacher might grade a little bit differently, so you don't know for sure which grade is really the better grade. So here's how we find out. We can use the Z-score to compare two different classes with two different grades. So here's our Z-score again, and I'm going to walk you through the whole process. So we're going to pretend that Mr. Hayden and Mr. Bremer gave you the class average, because we would need to know that for you to compare how well you did compared to the class. So here's your class average. I gave you this part, right, on your paper? Okay, so I gave you this much. So in science, you scored a 90. The class average was an 81. Okay, that's pretty good, right? You scored above the class average. Good. The standard deviation from the class was 7 points away. So let's picture what does that look like bell curve-wise. I just want you to have an idea. Actually, let me do it underneath, then it will make more sense. What does this mean? What did they just tell us just now? Okay, so here's the curve for science. Oh. There's your curve for science. The mean is 81. Can you guys draw this with me real fast? I just want you to have a visual. What does this look like? Okay, a standard deviation is 7 away. So what score would be 1 standard deviation away? So 81 plus 7 would give us 88. You still with me? That's adding the 7. And what would it be in the other direction if I subtracted 7? There you go, 74. So just picture what we have so far. Here's my bell curve for the class. I know that the average of the class was an 81. I know that most students are always within 1 standard deviation plus or minus. Look where you were. What did you get? Ah, you got a 90. Where's a 90 at? Like put a little dot right here. You're like right there. Go you. That's exciting. So you would be within 2 standard deviations because you would be within the next grouping of 7. You guys okay with what I'm saying? You'd be within the next grouping of 7. Let's compare that to government. Can we do another bell curve? So here's my bell curve for government. The class average was 77. This time, this class had a bigger span for their standard deviation, right? Most students got within 11 points of the average. So that means on the high end, what would be plus 11? 88. And on the low end, minus 11 would be 66. Again, that's not the whole class, right? That's just, we're talking the majority of the class. What did you get? Ooh, you got a 92. That's really close. Got a 92. So in both cases, you guys are going to be in the second standard deviation away from the mean. You did great. But which one is still better? Because see how they're both really, really close? We're going to use this formula and we're going to figure it out. So watch how we're going to do it. I just wanted you to have a visual of what does it look like? What does this bell curve look like? Here's how we do it. It's not hard. Just plugging and chugging numbers. So let's do science. Oh, wrong color. I'll do government down here. Let me switch back to my other color. I'm a visual learner, in case you can't tell. I like my colors. Okay, science. For the science Z-score, we're going to take our score minus the average. So our score was a 90 minus the average, which is 81. And we're going to divide it by the standard deviation, which is a 7. We okay with all three of those numbers where they came from? They gave it to us in the problem. So I'm going to get 9 divided by 7, which is about 1.29. Now let's try government. In government, your score was a 92. We're going to subtract our average and divide by 11. So I'm going to get 15 divided by 11, which is about 1.36. So which Z-score is better? Government. Yep. So we're going to say which score is better relative to the other scores in class? Government. What I don't want you to do is look at your initial numbers and say, science was a 90, government's a 92, it's government. That's not how we have to figure it out. Does that make sense? We have to use our formulas. Because again, it depends on the class and on the average. Like you see what a big span it was in government, and you were still outside of that range, which means you did a really, really good job. So you always have to take into account your score minus the average divided by the standard deviation. Good. Good job. Any questions on this one? So it will ask you to practice these, find these. And last thing for today is talking about correlations and lines of best fit. So this is kind of the end of Unit 9. And this should be easy. So if I'm looking at these graphs, I'm going to ask myself, is it a positive correlation, negative correlation, or no correlation? Guess what correlation means? Correlation is your slope. Can you circle that word? Correlation is really your slope. It's just hiding. It's calling it a new word. What I mean by that is, let's look from left to right. What's happening to our graph? So let's start on line number 1. If I start at the left and I go to the right, what's happening to my dots? They are going up, positive. So that's a positive correlation. That's easy. Let's skip over to number 3. As I go from left to right, what's happening to my dots? They're going down, so that would be a negative correlation. Now the one in the middle, what do we think? They kind of up, down, up, down. What do we think? That would be no correlation. That was easy. Now there's one more thing it asks us to do. It wants the strength of the correlation. Strength could mean we have a couple options. We can say strong or we can say weak. Only have 2 options. So if there's no correlation, then obviously we don't talk about the strength of the correlation because there isn't one. So let's look at option A and option C. Is it pretty obvious which one's strong and which one's weak? Or which one's strong, which one's moderate? They might say moderate or weak, either one. So for the first one, we can say moderate or weak. I believe they use either word interchangeably, so I just want to make sure you guys are comfortable with both vocabulary words. And then the last one would be strong. The only last thing they're going to ask you to do is draw in a line of best fit. It sounds just like the word says. What does best fit mean? It's going to be the best possible line that's going to cut through the middle or the average of our points. So let's try and draw them on your paper. So my first one might look like maybe like that. Here's my question. Are all of our lines going to be in the exact same spot? No, and that's okay. That's okay. And then our last one might be somewhere like that. Does the middle one get a line? Nope, doesn't get a line. What if I ask you for the equation of that line? Oh, because I'm going to, because you know that they do that to you. Okay, in order to write the equation of the line, we're going to do one more problem together, wrap up the day, and we'll end with that one. So, whoops, I'm giving you way too much information on screen at one time. Okay, there. Let's pretend I give you this table. Jim's parents record their son's weight for the first 6 years. Predict Jim's weight for year 9. So people actually use this stuff in real life for prediction, talking about the line of best fit and what's going to happen to the line as it continues on down the road. I don't track my kids' weight. I track their height, right? So for a little while, your height is pretty steady. Is it steady your whole life, though? No. Like, I couldn't say, I wonder how tall he's going to be when he's 50 and, like, use my line. Like, that's not going to work because not everything in life is linear. But let's just pretend that this example is linear. The first thing I'd like you to do is make a scatter plot. So part A says make a scatter plot. What is a scatter plot? A scatter plot is just a graph, just a graph. So can you guys make a quick sketch of your graph? Which number do you guys think goes on which axis? So I'm talking about years, I'm talking about pounds. Just think about it for a minute. Good job. The years are going to go on the X, the weight's going to go on the Y. Here's how I always think about it. The one that's consistent, meaning it has the same increment every single time, should be your X. Should be across the bottom. That way when we're graphing it, I'm going to have a dot at 1, I'm going to have a dot at 2, I'm going to have a dot at 3, I'm going to have a dot at 4. Does that make sense? So the one that's your X is your consistent number, the one that you're going to have a constant increase. Notice when I made my y-axis though, even though I have crazy different numbers in here, right? I have a 15, a 23, a 28, 35, 48, 50. You still have to use increments. You can't just put the number 15 as your first one, the number 23 as your second one. They have to have consistent increments. You could have gone by 2s, you could have gone by 4s. This case, I just happened to go by 6s, but there's no right or wrong answer as long as you're consistent. If you wanted to count from 1 to 50, be my guest, you could do that. Just probably not the best use of your time. So I don't want you to get wrapped up in, oh, she chose 6, I have to choose 6. No, you don't have to go by 6s. There's more than one right answer. Okay, so far everybody okay? Your graph might look a little different. In the long run, we're going to get the same answer. So in order to predict Jim's weight, think about what we have so far. We have years 1 through 6. They want to know year 9. So they want to know when my line's way over here, where's the line going to be? Do you guys see what they're asking? Okay, so there's 2 ways to do it. We can approximate it by extending our line, or there's a mathematical way to do it, which is probably what the quiz is going to ask you to do. So we're going to try one together and call it a day. So part B says, select and record 2 points to sketch a line of best fit. So they're picking 2 specific points to draw their line through. They picked the first 2. They picked 1, 15 and 2, 23. If you picked 2 other points, your line would be slightly different than mine, but it's still not a wrong answer. I know that's weird in math to pick a different number and not have a wrong answer, but it would not be a wrong answer. But for the sake of this example, everybody's going to pick the ones that I'm picking. Can you make those really big and bold on your graph and circle those 2 in our chart? Any questions on A or B so far? So making the scatter plot or picking 2 points? Okay. Part C says use the 2 points to find the equation of the line. Equations of the line, it's been a while. It's y equals mx plus b. I need to fill in a couple letters there until I have my formula. How am I going to do that? I need to know M and I need to know B. Okay, so you could use point slope formula. Yep, you could. Or how do we find M first? No matter what formula you use, we're going to need M. Who remembers how to find slope if I have 2 points going on here? I have my 115, I have my 223. How do I do slope? Do you remember? Yes, so it's y2 minus y1 over x2 minus x1. It's been a while, yeah? I know they're kind of pulling out all the stops here. So we will get 23 minus 15. What is that? 8. 8 over 1. Yes? Okay. So my M is 8. So far I have y equals 8 x plus b. All right. How do I find b? You're this close. We're almost done. Okay, so b is the y-intercept, but I would be guessing, sort of, right? Because I don't see exactly where it crosses because I don't have a point for 0. So I would sort of be guessing. Here's how you can find the exact point. Guess what 1, 15 or 2, 23 is? What is that? Your x and your y. I'm going to plug it in. So for y, we can pick either one. We'll get the same answer. I'm going to pick 15 equals 8 times 1. Do you see what I did? I took my y equals 8x plus b, and I'm just plugging in an x and a y. So I'm going to get 15 equals 8 plus b. What's your b? 7. Fabulous. Let's write my equation. So I have y equals 8x plus 7. Isn't that probably where we would have estimated it anyway? Look at my line. Doesn't it look just right above 6? It does. You guys did a great job. That's part C. So we used 2 points to find the equation of the line. What were our steps again? We found the slope. Once we found the slope, I had to plug in one of my points to find my b. So far so good. One last thing to do. Now I'm going to use my equation to estimate my prediction. Remember, this is the equation of the line. So I could either extend my line and try and figure out where is it at year 9, right? That's the spot I'm looking for. Or I can use my formula. If here's my formula, and I want to know year 9, what am I going to do with the 9? Plug it in. Which one does 9 get plugged in for? For y or for x? X, how do you know? Okay, and the 9 represents the year. Would you guys agree? The year is your what? X. Here's your x. So if I'm talking year 9 and 9 is my x, I'm going to plug it in for my x. Let's try. So I will get 72 plus 7, so 79. So he will be 79 pounds at year 9. Let's just make sure that we have that on our paper somewhere so we have a finishing sentence. 79 pounds when he's 9 years old. Now, does our weight keep increasing at the same weight forever? No. So I could not use the same linear chart to figure out what I'm going to weigh when I'm 100, because I would be like 500 pounds. That would be scary. But for certain things, we can use lines like this for predicting. Just know that it doesn't extend for forever, and it doesn't always make sense to talk about forever in terms like this. We did a lot today. Just kind of think over our steps. We made a little plot. We picked any 2 points. We used those points to find the slope. and your x and your y, and then we used our formula to plug in and find our prediction site. This is going to be happening a lot at the end of this unit. So that kind of wraps up week 18 for us. This is our last live session together. I'm still going to be available next Wednesday on campus if anybody wants tutoring before the next test, before your final exam. And then Thursday, Friday next week, I'm out at a math conference. So next week's open. There's no video to watch. I'm just here and available if anybody wants one-on-one tutoring. So if you missed the essential question, please go back and rewatch the recording. Otherwise, have a great week.